Welcome to my accounting knowledge sharing platform. My name is Dean. In today's video, we'll look at how to calculate this kind of problem. So whenever you have been given a question, either home loan question or personal loan, I'm going to show you how you can solve those kind of questions. And if you need any help, please let me know under the post if you have related questions like this. So let's look at the question that I have for you today. And these videos which I'm making here are only for educational purposes. They're not professional advice. If you need help in the areas where we provide services like general bookkeeping or QuickBook consulting, please let me know under the post and we'll be able to help you. So let's look at the question. This question says, Gabriel can afford to pay $2,500 per month. If he applies for a loan, which will charge 6.35% fixed rate, this is interest rate, per year for 10 years compounded monthly, how much loan will he get? So what this question is asking you is how much maximum loan Gabriel will get from the bank if he can afford to pay this one monthly. As you can see from here, we have this one per month and it is going for 10 years. We have this fixed rate. If interest changes, and then there will be changes in the amount here and the time. So make sure you understand the question clearly before you work out any problem. So this is present value of an annuity. And this is ordinary annuity. The formula for ordinary annuity is the present value of an ordinary annuity formula is present value, which is present value equals regular payment, which is this one here. Regular payment, 2,500 times, and since this one is present value of an ordinary annuity, we will have 1 minus parenthesis 1 plus R. R is 6.35%. And whenever you're working out this kind of problem, you have to change this into decimal. And the way I simplify this, because we don't have a space here to put everything, is to put that 6 point, whatever interest given, divide that by how many times this interest is compounded. And in this case, it says compounded monthly, which is 12 times a year. And then you add 2 zeros to change this into decimal. And then close parenthesis, and this raised to the power of NT. NT. And N is the number of times interest is compounded a year. And it says compounded monthly, that's 12 times a year, times T, which in this case is 10. So 120. Okay, so what you will do, you work out this first, raise to that power, and then whatever you get here, subtract this from 1, and then you have divide this part by 6.35. 5 over 1, which is this part. So now, the maximum amount the question is asking for, how much loan will he get? So the question is asking you to find how much maximum loan he can get from the bank. So this will be, let's use our calculators now, or you can use your phone calculator if that's what you have. You work out this part first, what is in the bracket raised to that power. And once you have that part, subtract whatever you got here from 1. And then divide that by what you have here at the bottom. So what you will have from this side, you have that regular payment, which is 2,500 times 8.66328.509. This part is what we call present value of an ordinary annuity interest factor, the one you have here. So what you will do now is to multiply by this present value of an ordinary annuity interest factor by the regular payment. What you will get, you have $sign there. This is 228.2127. So if you want to round this one to 2 decimal places, you can drop that 2, and that will be 0.21. If you leave it that way, it's all up to you based on the instruction you may get from the question. This is the answer you will get, and this is how much loan Gabriel can get from the bank. This is the maximum amount. If this interest rate remains the same for the duration of 10 years, and that is still compounded monthly, and this amount doesn't change. So if you have any questions, please let me know under this post, and we'll work together to solve that. I hope this is clear. Thank you so much for watching, and see you again in the next video.